Hey Precalc students, welcome to today's lesson on bearing, aka direction. I'd like you to take a couple minutes to read what's written up here, the description of bearing, how to find it, etc. So go ahead and pause the video and you can push play when you're done reading all of it. Okay, as you read example 1, it's asking you to use the compass rose. So in case you've never heard of a compass rose is this guy over here. Okay, kind of looks like a star, right? You're going to use it to identify the bearing described by the angle. So the main things about a compass rose that you need to remember is that when you're using it, you're always going to start from the north-south line. So think about your X and Y axis, right? So the north-south line is the Y axis and the east-west line is the X axis. So you're always going to measure from the Y axis, aka the north or south line. Secondly, they're always going to tell you to go east or west from north or south, okay? So let's take a look at the first one. It says from the north, okay, so this first one, N 67.5 degrees east is from the north. They want you to go 67.5 degrees east, okay? So from the positive y-axis, and just remember, the north-south line is like the y-axis, right? And the east-west line is like the x-axis, okay? So from the y-axis, the top half of the y-axis, or the north part of the compass rose, you're going to go east, which is to the right, 67.5 degrees, okay? In a compass rose, each arm of the star or each spike is 22 degrees. So each is 22.5. Okay. So from the north, you're going to go 22.5. Another 22.5 would be 45. And then another 22.5 would finally give you that 67.5 degrees from the north going east. Okay. So if you notice, that lands on east, northeast. So the answer is east, northeast. Okay, let's try another one. From the south, so that's the bottom half of the y-axis, you're going to go 22.5 degrees, but west. That is to the left. So from the bottom half of the y-axis, aka the north-south line, you're going to go 22.5 degrees to the left. That lands you at south-southwest. This next one, from the south, you're going to go 67.5 degrees. Whoopsies. 67.5 degrees east. So from the south, now we're going to go east. That's to the right. You're going to go 67.5. So first little spike or tick mark or arm is 22.5, plus another 22.5 is 45, plus another 22.5 lands you at east, southeast. Okay, go ahead and pause the video and make sure that you can do this last one by yourselves. And then push play when you're ready. So pause the video, try this next one by yourselves, and then push play when you're ready to check. The correct answer is north-northwest. If you did not get that wrong, don't forget to ask when you come back to class. Let me know. Okay, again, compass rose and bearing is direction, okay? So it's an angle with direction. We're going to do a couple examples with bearing. So take a minute, pause the video, read the helpful hints. So pause the video, Read the helpful hints. Push play when you're ready to start. All right, for this first example, we're talking about a plane that is 120 miles north and 85 miles east of an airport. They are asking me what bearing that plane needs to take to land or to get to the airport. So the plane is the one that is going to have to get to the airport. Okay. So if you're talking about a north, south, east, west line, okay, the plane is starting. Let's put that in the center. Okay. So here's your plane. This is where you're starting. That's the plane. Okay. Feel free to draw a picture of a plane if you would prefer. Remember, this is north, this is west, this is east, and this is south. When you are trying to figure out what bearing it needs to take to get to the airport, you still need to kind of know where the heck the airport is, right? So the plane is north of the airport, which means that the airport is below it. Okay, so that means that it's got to be in quadrants 3 or 4. Okay, now, since it is east, the plane is east of the airport. Let's say I put the airport over here. Airport. Does it belong there or here? Which quadrant does it belong to? Well, it can't be here because then the plane would be west of the airport, right? And they said that the plane is east of the airport. So out of these two quadrants, the correct one is 3. So think about it. Remember, the plane has to be east of the airport. So to the right. East is to the right. So it's to the right of the airport. And north, right, means that it's higher. When you guys are trying to find bearing, you need to start from the north-south line, okay? So if I'm on the plane and I need to go towards the airport, I don't want to go to quadrants 1 and 2, so I'm not going to deal with the positive y-axis or the north part, okay? We're going to deal from the south. So from the south line, remember your bearing is always from the north-south line. From the south line, I need to figure out how many degrees to go so that I can get to the airport. In these problems with bearing, your 90-degree angle should be to the y-axis, okay? Okay, again, we're trying to find that angle. We don't know. What we do know is the sides of this triangle that we have created because we know that the plane is 120 miles north of the airport. So that's the same distance over here. Okay, that's 120 as well. You got to look at symmetry here. And it's 85 miles east. Okay, so the 85 goes here. If you're trying to find an angle, you need at least 2 sides to find it. So I'm going to set up an equation, that uses opposite. Okay, so this side is opposite from the angle, opposite and adjacent, because we don't know the hypotenuse, nor do we need to. If they would have asked me how far does the plane have to travel to the airport, they asked for distance, then I could find it using the Pythagorean theorem, but that's not what they want. They want bearing. Remember that bearing is an angle with direction, like we used in the compass rose, okay? All right, so here we go. The trig function that would allow me to use opposite and adjacent is tangent. So tangent of the angle equals opposite over adjacent. To solve this, I need to use inverse tangent. That's second tangent on the calculator. Second tangent. Okay, so pause the video for a second. Try it on your calculator. Inverse tangent or second tangent of 85 over 120. Also, make sure that when you If you're not getting the same answers as me, it could be because your mode is on radian instead of degrees, so you'll have to double check that as well. All right, I got 35.3 degrees. But remember, bearing is not just an angle, it's an angle with direction. So if we start where the plane is, right? The plane starts, let's say right here at the origin, right? It has to go from the south line west to get to the airport. So the correct answer is not just 35.3 degrees. You have to say from the south line, it has to go 35.3 degrees west. Okay, remember you can pause, rewind, rewatch the video as many times as possible until you understand the material. But I'm going to go ahead and move on to the next one. A ship leaves a port at a bearing of south, so here's your bearing, south 27 degrees west. It travels on that course for 20 nautical miles. So that's distance. It's really important for you guys to understand that miles is distance. Now, the reason they call it nautical miles is because traveling in a vehicle on land is a little bit different than traveling on water. So instead of just saying miles, you say nautical miles. Nautical has to do with like water, traveling on water. How many nautical miles south and west has it traveled from the port of origin? So first and foremost, when a ship leaves a port, just so you guys know, a port is like a docking station, aka like a parking lot for boats. Okay? A docking station, aka parking lot. So I'm going to go ahead and put my ship, my start. Okay, this is where I start. This is my ship. We have a bearing, so we're going to go ahead and draw the north, south, east, and west line. And we know that from the south, okay, so remember, bearing is always from your north, south. It's either from the positive positive y-axis or negative y-axis. In this case, it's the south, so that's the negative y-axis. So it goes from the negative y-axis, which is from the south, it travels west. So that is to the left, 27 miles. Now, I drew the angle a little too big, super sad. Doesn't have to be perfect. That looks more like a 45-degree angle, but you get the idea. So 27 degrees. Okay, remember your 90 degrees should always be to the y-axis. Now the ship travels on its course. So here's the ship. Here it goes, here it goes, here it goes, here it goes, and ends up over here. Okay, so it traveled that way. That's where the 20 goes, which is the hypotenuse. Now notice they're asking me two questions here. They're asking me how many miles south did it go? Okay, so that's this distance over here, this vertical distance. And they're also asking me how far west it went. Okay, so we can't solve a trig equation with two missing pieces. So like the Pythagorean theorem doesn't work here because I only have the hypotenuse and none of the legs. So I need to find a trig function that will help me find one of those sides at a time. So let's focus on x. X is adjacent to the 27. So which trig function allows you to use adjacent over hypotenuse? That's cosine. Cosine of 27 degrees equals adjacent over hypotenuse. And then you're going to set up another equation. In this case, the y would be opposite. So that's opposite over hypotenuse. And for that, it's sine. And to solve both of these equations, you're going to multiply both sides by 20. Okay, here's another one. Same thing, both sides by 20. Okay, so take your calculator and multiply 20 times cosine of 27. Remember, you need to be in degree mode. Pause the video and you can unpause it when you're done solving these equations. We're rounding sides to the nearest hundredth and angles to the nearest tenth. So since these are distances and lengths of the sides of a triangle, these are going to be rounded to the second decimal. Remember, pause the video, try yourself, and then push play when you're ready. Okay, so notice that I'm writing the units, nautical miles, and I'm also saying what direction it traveled in, right? Because they asked me how far did it travel south and west. So you have to be really specific in your answers. Okay, moving on to the next problem. A pilot traveled at a bearing of south 57 degrees east. So I'm going to go ahead and kind of start with my x and y axis, which are my north, south, west, east line. So here's my pilot. That's where I start. And from the south, I'm traveling east. So this is your north-south line. From the south, I'm traveling east. Okay? So there's the 57 degrees. You're going to draw your 90 degrees always to the y-axis. Now, they want me to tell them how far, so it's traveling, it starts here, then it starts traveling to, we don't know. It's just traveling somewhere. It's going to end up somewhere, okay? We don't know anything. They only gave us 2 other numbers, but here's the deal. None of those are angles, okay? Not the 245, not the 245 miles per hour, and not the 2.5 hours. None of those are distance. So those are not lengths in the triangle because the triangle represents how far the pilot traveled. Okay, so none of those are distance. So you have to go back to physics and remember that distance equals rate times time, or velocity times time. So in order for me to convert these into distance, I need to multiply them. So the 245 times 2.5 together will help me find out the length of one of those sides. So it's 612.5. Okay, now pause the video for a second. Make sure that you understand that alone, the 245 and the 2.5 could not be plugged into any of the side lengths or angles of the triangle. And now I want you to think, okay, now that we know that together they make a distance of 612.5 miles, where would that go in your triangle? So pause the video and figure out where would that go in the triangle. Push play when you're ready. It's the hypotenuse, right? That's the path that the pilot's going to take. So that's the hypotenuse, 612.5. So they're asking me how far south. So south is a vertical value, right? North and south goes up and down, and east and west goes left to right. So you're going to set up 2 equations. And if you're looking at just the x, according to the 57, that one is adjacent. But when you're looking at the y from 57, that is the opposite side. So we're going to use 2 equations. Let's take a look at just x. If we're looking at just x, we want to use adjacent over hypotenuse, which is cosine. So cosine of 57 equals, excusez-moi, say the French, adjacent over hypotenuse. Multiply both sides by 612.5 and find your answer. You're going to set up another equation using the 57, the y, and the 612.5. That one is going to require the use of sine. Sine of 57 degrees equals opposite over hypotenuse. Again, multiply both sides by 612.5 and you should get your answers. Okay, pause the video, push play when you're ready to check yourself. Check yourself. Okay, and then the distance that the pilot has to travel south is 333.59 and east is 513.69 miles. I hope that you, if you're watching this video, I hope that you listened when I told you to pause the video and try it on your own. All right, guys, as always, if you need extra help, let me know. See you soon. Bye.